Okay, so we're solving this equation, but for one period, basically, or one revolution around the circle, meaning I'm going to restrict the number of solutions. Because if I don't say this, then you have an infinite number. So we're going to do one for a finite set versus an infinite set. So let's start with this first. This is finite. Okay, so just go ahead and solve for, isolate the sine function. Treat that like your x, your x variable. Okay. So subtract 7 on both sides. That would give you a 2, right? Minus 7, minus 7. Divide by 4 on both sides. Let's show that stuff this time. So sine theta is equal to 1/2. Okay. Now there's a couple of ways to do this. You can take the inverse of both sides. So sine inverse of sine, which will cancel the sine. Sine inverse of 1/2. So theta will be equal to 30. Let's use degrees just to keep it simple for now. I'm going to call that my first angle. Now there's more than one place that you get a half for sine. So to find the second, what you do is subtract from 180 degrees when you're dealing with sine. So there's the two angles that do this. Now let's open the circle that I gave you a long time ago. Let me find mine. Here it is. All right, so remember, they're asking for the angle that gives you a y value of 1/2. That's what the equation is asking, right? Once we isolated the sine. So there's one here, and there's one right there. Over here, y is negative, so we're not going to include this bottom half of the circle. So there's two sections, here and there. Notice how it's 30 degrees. So this is given from your calculator, or just looking at the circle. Who cares? Then 180 minus that angle will give you 150. Okay, so that's how you get the second one. Technically, because this is an easy example, you can just look at the circle and say, oh yeah, it's right there and right there. Who cares, right? But if I were to have given you a really weird number, like let's say it wasn't a half, let's say it was like 1.2 or whatever, right? Then you want to use this method. Use the calculator to find this first one, and then find the second by subtracting from 180. So no matter what number I give you, no matter what number you have here, sine theta equal to whatever, you can still do this. So you can still solve for the two angles, okay? So those are the two solutions from 0 to 2 pi. Is there any questions about what we did there? Pull out the calculator just so you can see. Fun. So second, sine inverse of 0.5. What am I in? Radians. Let's go switch to degrees. Do it again. 30 degrees. So that gives me the first one. To get the second, I must do this. And then you get 150. Okay. Is that clear? Let me know. If not, I'm going to move on to part B. So now this is saying solve for all theta. In other words, I am no longer restricting you to one revolution around the circle. I'm telling you, you have no restriction. You can go around the circle forever. So what you do is you use these solutions to help you out. All right, so let's look at the circle to get an idea of what this means one more time. So do you agree that if I'm right here at 30, if I add 360, 360 again, and again, I'm going to keep getting more solutions, right? I'm going to keep landing on there. So the solution would be, in general, 30 degrees plus 360 times n, meaning how many times are we going to go around the circle? Same thing for this guy. 150 plus 360, 360, 360, over and over again. I can keep getting solutions. So what you say is the first set of solutions is 30 degrees plus 360 times n, where n is some integer. Sorry, maybe use English here. Where n is an integer. Does that make sense what I'm saying here? You see how if n is 1, then I go around one time and land on 30 degrees. If n is 2, I go around twice and land again here. Because these functions are periodic, I can do that forever, right? If n is 0, well, I get the original. If n is negative, well, I go the other direction. I'm still going to land here, no matter what. So use the answers from part A to find the solutions for all n. So I take 150 and just add 360 n, where n is an integer. So once you have the first part, the second part is no big deal. I just want you to make sure you understand what I'm saying here by 360n. Is that clear? Okay, so let me show you on our homework. They say solve the equation, and notice how they have like something plus 2 pi n. So this is like 360n. And if you solve this one, you're going to find the angle and then just add the periods. Will make you land on those spots over and over again. Okay. None of them appear to restrict you to one period. They just say solve. Oh, here we go. Finally, 13 is the one where they finally say, you know what? Only tell me the ones between 0 to 2 pi. And you get the two answers. So unless they restrict you, you will have to add 2 pi n. Okay. And we'll get to that in a moment, but I mean, that's what we just did on part A, but we'll do harder ones in just a moment. Let's try, well, let's see if I have one more question that's still easier before we get to the homework problems. 1 second. on, still looking. Let's do, yeah, this one's fine. Do one more easy one, then we'll move on to the homework. So what I recommend, even though they don't tell you to solve for one period, just go ahead and solve it for one period. That way you can just add, you can just tack on the n pi, I guess. Okay. Solve the equation. 8. Oh, this one's a little annoying, but not too bad. Cosine squared theta equal to 6. So 8 cosine squared theta equal to 6. So first step, divide both sides by 8. You need to isolate the cosines, or whatever trig function you're dealing with. Isolate. 6 divided by 8 becomes what? Is that 3 over 4, right? Yeah. Then you have to square root both sides to isolate that cosine. But when you square root both sides, you have to tack on a plus or a minus. And just the rule for square rooting. So cosine theta is equal to plus or minus the square root, actually, square root of 4 is 2, so you only have a square root on the top, technically. You see that, how the 4 will come out? Square root 3 over 2. Okay, now I have two solutions here. This is the same thing as saying cosine theta is equal to square root 3 over 2, or cosine theta equal to negative square root 3 over 2. Just in case it wasn't obvious, that's what we're saying, which means we have a bunch of little locations for that. Now, cosine is the x, so excuse me, square root 3 over 2, it's right there. Negative square root 3 over 2 is right there because we have a plus or a minus, so both are cool. Both are technically solutions. There's another negative root 3 over 2.
Those are both considered solutions for cosine?
Yeah, because we have, because of the plus or minus.
Okay.
So we're gonna have 2 locations for this one and 2 locations for that guy. So that means we have 4 angles that will satisfy this. So looks like 30 degrees, 150 degrees, 210, and 330 are all answers. Okay. So you could write all 4 of them. Well, since the first question, well, it didn't specify, so part A, let me specify it now. Part A is, let's see. Ah, here it is. Solve for theta on interval 0 to 2 pi. Right? So that means that the first theta will be, this time I'm going to use radians, okay? This is pi over 6, which is 30 degrees. Theta 2 is going to be 5 pi over 6. Theta 3 is going to be 7 pi over 6. Theta 4, it's 11 pi over 6. Okay, so there's our 4 solutions that we saw in the circle just a moment ago. So all you have to do is technically tack on 2 pi n on each one for part B. So part B says, find all solutions for theta. So I'm not restricting you anymore. So what you could say is theta 1 is pi over 6 plus 2 pi n. Theta 2 is 5 pi 6 plus 2 pi n. Theta 3 will be 7 pi 6 plus 2 pi n. Theta 4 would be 11 pi 6 plus 2 pi n. Although you could technically shorten it, right? Now, we said pi 6 was a solution, right? Or 30 degrees, because cosine is square root 3 over 2. You agree that if I add 360, I'll land here again, 2 pi, over and over again. But if I add 180, or I should say, if I add a pi, I would end up over here, right? Which is the other solution. So technically, I could just say this one plus pi, n pi, to get me these two at the same time. So you could say that, you know what, let's shorten this and say that the solution is pi 6 plus pi n, and the other one would be here and there. So that would be 5 pi 6 plus pi n. So either one would be fine, but I think the first one makes more sense, right? Anyway, is there any questions on what we did here? I feel like I might have gone a little fast there.
Sir, could you hold on a minute so we can write it down?
Yeah, no, of course.
Sorry about that. Thank you. Sir?
Yes.
I wrote it all down and I was listening to you the whole time and I still managed to like fail to understand something.
Sure. Where would you like to start?
Why are you able to, well, can you like just put it in plainer English? Like, why you're able to get rid of the 2 on the 2 pi n in theta 1 and theta 2?
Yeah. I mean, it all comes from looking at the circle here. So you agree that if we find all four, all you have to do is add 2 pi and 2 pi, right? To get the same one over and over again forever.
Yes.
But if I add pi, do you see how I'll land on the other location, which is the other solution, 7 pi 6?
I mean,
Like
yeah,
from here to here is 180 degrees, right? Or in other words, pi degrees.
yes.
So if I add, instead of doing 2 pi, I can do n pi. So 1 pi, 2 pi, 3 pi. So see how I'm landing on those two spots over and over again? So I can kind of condense, this one and that one into this.
I'm trying to think of a way to write that in my notes so I will actually understand it later.
Um,
You get what I mean? Like I might understand what you're saying right now while you're showing me. But if
mhm.
I had to think about it later, would I be able to understand it later?
I don't know. I mean, I guess it depends on you. Trying to see here. If there's an easier way to explain it.
I can't think of a way to write it down. Oh well, I'll just probably put 2 pi n on everything anyways.
I mean, yeah, that's totally fine to do that. It's just that if you land on the same spots over and over again, you can kind of just combine them together. This only happened because we had the plus or minus, right?
Yeah.
So if it was just a regular one, we wouldn't have so many. If it was just one of these, we would only have 2 or so.
I just won't be marked wrong for putting in a 2 pi n, right?
No, it's just it's kind of like computer programming, right? You could code something faster or a little bit slower. It's the same thing.
All
Nobody
right,
cares. Nobody cares unless you're working for Google.
that's fair.
You want some extreme, what's the word? Efficiency. It's the only time it matters. Okay. But so far, is this making sense what we're doing? We're solving for different angles given some value. Is it okay? The main idea. Okay. So let's move on to the homework questions because those look a little bit harder. Look at number 5. They start with like the first equation is a cosecant. I'm like, okay, well, I guess could have started easier, but whatever. You guys cool on this page? Sorry, I don't mean to switch too quickly. I'm assuming you guys are good then, I guess. Number 5. So this is example 3, problem 5 from your homework. Solve the equation square root 3 cosecant x minus 2 equal to 0. So I'm going to start by moving that 2 to the right hand side. So square root 3 cosecant x is equal to 2 if I add 2 to both sides, right? Now I'm going to divide both sides by square root 3. So cosecant x is equal to 2 over square root 3. That okay so far? What is cosecant as a reciprocal? Isn't this 1 over sine? Do you agree? From your identities? Now, if I were to flip both sides over, do you see how this will become square root 3 over 2? Taking the reciprocal of both sides, flip them both upside down, we get to there, which is a point on the circle, right? Square root 3 over 2 is right here and right there for sine. So if you were to use the calculator, let's say you did sine inverse of both sides, right? X or theta, if you prefer, will be equal to 60 degrees. I'm going to go ahead and use degrees this time for no reason. So my first angle is 60 degrees. So the second one we said will just be 180 minus 60, which is 120 degrees, which is what we saw in the circle anyway, right? We saw this, but this is how we would show our work, just using the calculator, pretending we didn't have a circle, or pretending these numbers were not on the circle, because sometimes that happens. Any questions on any of these steps here?
So far, no, but then as soon as we get off, I forget everything apparently.
That sounds really frustrating.
It is.
I know it's late, but I mean, what my professors used to tell me was right after class, go do homework so you don't forget. But I know most of you probably go to bed. But if I mean, the best thing I would say is try and practice as soon as you can before it starts to fade. That way you can kind of solidify it.
I get up for work at like 4 or 5 in the morning.
Man, that sounds horrible. I'm sorry.
It's all right. It'd be what it is.
Yeah, I guess so.
Be what it is.
Yeah. Well, I appreciate you being here so late when you get up so early.
Well, it's all right. You know what it is. Oh, sir, are we done with class then today?
Not quite. Almost there.
Okay. Like we're
I've-
chatting like we are.
I'm just getting a little distracted here. Let's see. But let me show you the homework. I mean, the rest are all very similar, but I feel like we should do a couple more. So notice they answered this question we just did in general, meaning for all theta. We solved it for one period, which is what I asked for in the last example. So the homework examples are not telling you all theta or whatever. They start off with just assuming, how do I phrase this? The homework starts out by just basically assuming you're going to find all solutions. So you have to tack on this piece. And they also tell us to use radians. So we shouldn't quite stop yet. Let me finish this problem. So in other words, x1 is equal to 60 degrees, which is pi thirds. X2 is equal to 120, which is really 2 pi thirds, using your circle. So what you should use here is pi minus pi thirds, which is equal to 2 pi thirds, if you were to do the radian version of that. Now the actual answer, you would say, well, the first one is pi thirds plus 2 pi n, and the other one would be 2 pi thirds plus 2 pi n. So you just have to use these pieces. So I recommend starting like this. I mean, if you want to use degrees, I mean, that's easier for you, that's fine. Just make sure you change it. If you want to just use the radians, that's cool too. I don't care. But if they want radians at the end, make sure you convert. Okay. Any questions on number 3? Okay. Let's look at number 9, I guess. That one looks a little different. So this whole section, you're actually just solving equations, not doing anything else. Cosine cubed x minus cosine x is equal to 0. Okay, so whenever I see something like this, I'm thinking I should try to factor cosine x from the entire thing. So that would become a square minus 1 equal to 0. Now the zero factor property says if you have a factored two factors like this equal to 0, then you can set each piece to 0. It's like back in old school algebra. So this will become, right, square root both sides, so cosine x is equal to plus or minus 1. All right, so now we got to find these answers. Look at our circle. So where is cosine equal to 0? Looks like right here. Pi 2, 3 pi 2. These two locations, right? When is it equal to 1? Well, it's going to be 0 and 180. Let's look at the question again. Cosine cubed. That's weird. No moment. Why not? 1 time. Oh, I see. Okay. Sorry. All right, so you agree that the solution for this using the circle or your calculator is equal to, so x1 is going to be on the circle 0. X2 will be pi over 2. X3 will be pi. X4 will be 3 pi over 2. Now, if you're wondering where those numbers came from, look at your circle. X cosine is 1 here, cosine is 0 there, cosine is -1 here, cosine is 0 there. So those are my 4 locations. 0, pi over 2, pi, 3 pi over 2. And it starts to repeat. What is the distance from here to here?
Pi over 2.
And you notice how this is the same thing, right? Over here is another pi over 2. And again. So the solution to lump it all together in general terms is that x is equal to pi over 2 times n. So when it's 1, 2, 3, 4, 5, 6, it will land on those spots. Any integer, actually. Because we want to know when is cosine 1, when is cosine -1, when is cosine 0. Those are 4 different locations. That makes sense?
So how does the answer actually look in the homework? Like if you were to put a box around the actual answer, is it literally the pi over 2?
Yeah, pi over 2n. So they want you to enter your answer. Use n as an integer constant. So pi over 2 times n. So n is either 0, 1, 2, 3, 4, 5, or -1, -2, -3, -4, forever. And I'll keep landing on those spots on the circle. So it helps to have the circle with you unless you decide to memorize it. Which I don't require you to do. Does everyone see where those angles are coming from? Because the first piece was finding them, but they went ahead and combined them into one that represents all 4. So we're trying to, I guess, basically try to get a solution that represents all the spots if you can. $11 looks different. Same with cosine. Let's do 11. Oops. Five? Yeah, 5. Okay, so 2 cosine squared x plus cosine x minus 1 is equal to 0. So what I want you to do is pretend that w is equal to cosine x, just for a moment. So that would mean that we have 2w squared plus w minus 1. This is easier to factor, right? This should look very, very familiar. Remember, we would do the whole, I mean, there's a couple of ways, but we do the whole AC method where you do 2 times -1. Then you find the sum of factors. Or you could do brute force if you want. So you say the factors of -2 is either -1 times 2 or 1 times 2, which one adds up to 1 times -2, which one adds up to the center term. Well, that looks like this guy. So you then break up the middle term like this, right? So I broke this guy up to here. There's a quick review on factoring a quadratic from old school math here. So then factor this guy using grouping. So these two terms have a 2w in common. So that'll be w plus 1. These have a -1 in common. Factor that guy out. Then you have these two in common. So you factor a w plus 1, leaving you with 2w minus 1. Right. So this is called the AC method, in case you forgot. Factoring a trinomial using this AC method. You could do
I have a
brute
question.
force. Yeah, what's up?
Where'd you get the -2 from?
So a times c means this here. So ax squared plus bx plus c equal to 0. So you multiply a times c. So right here, let's use our lowercase letters. A times c is equal to 2 times -1. That's what gave us the -2. So that's why you set this up. And then once you have this number, you try to find all the factors. You create a little list. And the ones that add up to the middle term are the ones you choose. So I'm choosing this one.
Gotcha. Okay.
So we're basically rigging the problem to be a grouping problem. So this is like very just a factoring refresher, I guess. Once you have it, we know that we can set this equal to 0, right? And we can solve for w. But w is just a dummy variable. Nobody cares about w. W is actually cosine x, right? So this is just a way to make it easier to solve the original problem. You don't have to do this. This is just what I recommend for you to do, because factoring is something you've done before. So if I make it look that way, it should be easy, right? And once you've done so, we can go back to trig form. And now we look at the circle or use your calculator, either way, whatever you want to do. Excuse me. Is there any questions on the algebra? You guys remember this? Is it okay?
So are the final answers -1 and 1/2?
No, not yet. We need to find the x's that do that. So all of that work was just to start this process. So what angle makes cosine -1? looks like pi, right? So the first solution is pi. What angle makes cosine 1/2? Well, there's one here and there, right? So the first one is this, and the next one is here. But they didn't say one period, so we have to tack on the 2 pi's, right? So the first solution is pi plus 2 pi n. The next solution is pi thirds plus 2 pi n. And x3 is 5 pi thirds plus 2 pi n. So we're factoring and isolating cosine in order to solve for the angle. So all the beginning step was just an extra thing because the question wasn't as simple, right? We had to, in order to isolate, we had to do algebra factoring here for a quadratic. Okay, the first one is you just isolate one function or whatever. See how there's just one of them? But slowly it gets more complicated where you have to do factoring or maybe an identity from last section or last chapter. Anyway, is there any questions on this problem? Okay, so just keep in mind that you're solving for all angles until they tell you not to. So it looks like 13 is the first one where they actually tell you, you know what, tell me for one period. So until then, they want you to tack on the 2 pi n or pi n, whatever it is. Alrighty. Well, that's it for today. You guys have any homework problems you're struggling with or any issues?
I just had that chemistry stuff.
Okay, we'll try that out in a second. All right. Well, if you guys have no questions, I'll see you next time. And if you start having issues with these problems, make sure you bring some problems for next time. Okay.